So now we're going to talk about the coefficient of determination, which will give us an r squared. You can see the formula for it right there, r squared. So it's that calculation right there. We're going to see about that in just a second. And we're also going to learn about sample correlation coefficient, which is just the square root of our coefficient of determination. So we take our r squared, which is this value here, and we take the square root of it, and it gives us the correlation coefficient. And if you remember when we were putting together a little notation sheet earlier in the year, we looked at correlation coefficient. And correlation coefficient went from went from -1 to 1. And so I put this on our little sheet right here that our sample correlation coefficient, it's going to go from -1 to 1. And our coefficient of determination just goes from 0 to 1. And we calculate our coefficient of determination by having SSR and dividing it by SST. So it's going to be this amount here, which is our SST divided into this amount. So SSR over SST, and that gives you the proportion of this distance here, the distance from the mean to the regression line, as a percentage of the total from the mean to the point for that ith point. And so it's a percentage. And what it measures is it measures how well this linear regression line explains changes in the dependent variable based upon the independent variable. And so you could see an explanation here of r squared. R squared is known as the coefficient of determination, and it's a measure of how well the independent variables in the regression model explain the variation in the dependent variable. It indicates the proportion of variance in the dependent variable that is predictable from the independent variables. So the range of it's from 0 to 1, and you can see 0 means that the independent variables do not explain any of the variation in the dependent variable, and 1 means that the independent variable explains all of the variation in the dependent variable. So a higher r squared value indicates a better fit of the model. So an r squared of 0.7, for example, will say that 70% of the variability in the dependent variable is explained by the independent variable in the model. And so here is like how ChatGPT describes it, and here's how the textbook describes it. And when we look at our example here, we have SSR over SST, and we get 90.27%. So the regression relationship's very strong. 90.27% of the variability in the sales of the pizza parlor can be explained, of the different pizza parlors, can be explained by the linear relationship between the size of the student population and sales. So the student population at a campus that the pizza parlor is near. So how do we get SSR and SST? So here's how SST is calculated. And SST is, if we look at our little diagram, SST, it's going to be the difference between an ith point and the mean. And so if we come down here and we have an ith point, a y point, and then we have a mean, so the deviation, and the mean is 130, so y mean, y bar is equal to 130. And that's because here our y's, they all add up to 1,300, and we have 10 observations, so 1,300 divided by 10 is 130. And with a mean of 130, 58 minus 130 is -72. 137 minus 130 is 7. And then if we square all those and then add those all up, we get 15,730. So that's our SST, 15,730. And then for the SSR, we could figure out our SSR by knowing the relationship here. SST is equal to SSR plus SSE. So if we subtract SSE from this side, we're going to have SST minus SSE is equal to SSR, or SSR is equal to SST minus SSE, SST minus SSE. So we know SST already is 15,730, and all we need is SSE, and that's 1,530, and it's given here in the textbook. And so you can see how the there's too many SS things here. SSE is calculated right here. Oh, calculation of SSE. So here is the size of the student population, each restaurant, 1 through 10, and then how many students were in the population at the college campus at the restaurants near. And then we have the sales that that restaurant does in thousands. So each of these are in thousands. And then we have our regression equation right here, our estimation. And so we put in here x. So if we put x in here, we get 60. And so maybe 60 plus what is that? 5 times 2 is 10 is 70. So these are 70,000. That'd be 70,000. So I was reading that 60 wrong in a previous video. And then our error is going to be yi minus y hat. And if we go over here and we look for yi minus y hat, that's going to be this amount right there from the dot to the regression line. And then we have our squared error, which is going to be this value squared, right? And so that'll be 1530. So that's how we get our SSE right there. And so when we have our SSE and our SST, we could get our SSR, which is 14,200. And with 14,200 over 15,730, we get 90.27%. And then that's our coefficient of determination. And that scale goes from 0 to 1. With a sample correlation coefficient, we just take the square root of our coefficient of determination and we get our correlation coefficient. And that goes from -1 to 1. And we put the sign of the slope in front of that. So it's just like we don't have to invent the engineering, we just have to know how to use it. We don't have to invent the engineering on the BMW, we just need to know how to drive the BMW. Again, here we're just like, if we understand what these things do, we can use them and we can make some sense of it. And so the coefficient of determination gives you a scale from 0 to 1, and it allows you to know, right, that 90.2% of the variability in sales can be explained by the size of the student population. So the dependent variable, 92% of it can be explained by the independent variable. Now for our correlation coefficient, we just take a square root of that coefficient of determination. And so the square root of 90.27 gives us 95.01. And here's how ChatGPT explains the correlation coefficient. You'll remember we looked at correlation coefficient earlier in the semester and we saw this notation right here. And here again is a different formula that you could use to calculate the correlation coefficient. And when I use that formula right here, and so I put that formula here, and I have my pizza parlors, I have the X value, so the size student population in 1,000. I have the Y value, the amount of sales in 1,000. I have XI, so this point, minus X bar. So X bar here, if I do like an average, equals an average. I'm trying to get this video done fast before, because I got to get home. And so there are my averages. And so XI minus X bar, 2 minus 14 is going to be -12. Here's yi minus y bar, 58 minus 130 is going to be -72. 137 minus 130 is going to be 7. And this is going to be d times e. So this amount times that amount gives me this. This is going to be d times d. So this times itself, right? xi minus x, right? And to get the squared value there, just multiply it by itself. It gives me this amount. And this is going to be the e column times e. So this times itself, like 7 times 7 is 49, okay? And that's when I need this minus this and square it. That's where I get that value. And then when I take these two values, which is this one here and this one here, and I take the square root of them, I get those. And then when I take those and I multiply them together, I get this, right? So this one is those two multiplied together. And then this is my numerator, 2840, which is that right there, d times e. So xi minus the mean, yi minus the mean. So this one times this one gives me that one. Add all those up, I get 2840. So there's my numerator, there's my denominator, gives me 95.01. And that is exactly the exact same figure that the textbook comes up with, 95.01. So you could also calculate it using ChatGPT's formula. So that is the coefficient of determination and the correlation coefficient. That was quick, I know, but I told my wife I wanted to record one more video and it'd be about 10 minutes, and I'm at 9 minutes and 34 seconds. So hopefully that made some sense. And again, just keep coming back to, I will pause things here for you. So at the end of the video, you can look at them like you want to know about that, and then you want to know about that, and then you might want to read this. And there's the calculation, and then you'll want to know that one, and you'll want to know that one, and you'll want to know that one. And then take the square root gives you your correlation coefficient, and then there's a little bit more right there. And then is this the last one here? That's the last one there. All right, have a great evening, morning, day, week, weekend, whatever it is for you. Hope you have a great time wherever you're at. See you next time.